Moving on to triplet loss. Triplet loss is a bit complex as compared to contrastive loss, and it has been seen that it performs better as compared to contrastive loss as well, because we will see why it happens. So the formula is maximum 0 comma distance between AP plus distance between AB plus alpha. So alpha is a constant. What is D? D is a distance function. So we are again calculating distance between AP and AB. Now what is AP and what is AB? So A is our actual image, P is a sample similar to A. So if we are trying to make a Simon network train on car images, so P would be something. So A is a car image, P is also something similar to a car image only, and B is something is a sample that is very different from sample A. Now it is based on the idea that the distance between AP would be very less as compared to distance between AB. Why triplet loss works better as compared to contrastive loss? So if you notice in the two formulas, in case of contrastive loss, we are inputting two images together, x1 and x2. While in case of triplet loss, we are inputting three images together. One is a similar and other is a different image. So in case of contrastive loss, how we are training, how we are preparing a training data set, what we are doing is we are we are creating two types of samples, two types of pairs of samples. So in one pair we put in images with same domain in the same pair, hence the output becomes one. So if we are training images on cars, so what we would be doing is that the other image would also be around cars only, hence the output becomes similar. While in other pairs we would be pairing up some random image with the actual data set. So whatever we are doing in triplet loss in just one iteration, that we are taking three images together in which one is similar and other is different. In case of contrastive loss, what we are doing is that we are doing the same thing but in parts. So some samples will be similar, some samples will be different, and hence the training for both the things won't happen together. In case of triplet loss, what would be happening is in the same sample training, the model would try to understand how to differentiate from random samples from the similar samples. So we have P and B coming together. But in case of contrastive loss, this ideology has been splitted into multiple pairs. So one sample will have similar pairs, other sample will have different pairs. Hence, training is comparatively less efficient as compared to triplet loss.